Infinite series. An infinite series is an expression of the form u sub 1 plus u sub 2 plus u sub 3 and so forth off into infinite number of terms. We will also write this as a sum as k goes from 1 to infinity of our u sub k's. The numbers u sub 1, u sub 2, u sub 3 are called the terms of the series. So informally speaking, this expression right here tells us to get the sum of the terms u sub 1, u sub 2, u sub 3, and so on. To carry out the summation process, here's what we're going to do. We're going to define the nth partial sum of the series to be the sum from k equals 1 to n of u sub k, so the first n terms. The sequence of these s sub n's is called the sequence of partial sums. If this sequence of partial sums converges to a limit s, then we say the series converges, and s is the sum of the series. So we would write either s equals the limit as n goes to infinity of our s sub n's, or we could also write it as a sum as k goes from 1 to infinity of our u sub k's. If the series doesn't converge, then we say it diverges and has no sum. So let's look at an example. For this infinite series, 3 over 10 plus 3 over 10 squared plus 3 over 10 to the cube and so on, this infinite series has the following partial sums. S sub 1 will be our first term. S sub 2 is the sum of our first two terms. S sub 3 is the sum of our first three terms, and so on. So S sub n is the sum of our first n terms. So as n increases, the partial sums include more and more terms in the series. So if we want to look at these partial sums, what they tend to as n goes to infinity, it's going to be kind of interesting to do because that number n keeps increasing. So what we're going to do is this. We know that S sub n is equal to this. Now suppose I just multiply S sub n by 1/10. Then that's going to increase the power of the denominator by 1. And if you look at that, the red terms in S sub n match the red terms in 1/10 times S sub n. So if we subtract these two equations, we'll get that S sub n minus 1/10 S sub n is this line here minus this line. All the red terms will be canceled out, and all I'll be left with is this first term here and this last term here. So now taking this equation, on the left-hand side I can factor out an S sub n and then simplify to get 9/10 S sub n. And on the right-hand side, I'll factor out a 3/10 to get this equation here. And then to solve for S sub n, I'll multiply by 10/9, which gives me this formula for my S sub n's. So now that I have a formula for my S sub n's, I can go ahead and find the limit as n goes to infinity. So as n goes to infinity, my S sub n's tend towards the value of 1/3. So we can say that the sum of this infinite series is equal to 1/3. For our next example, let's look at the infinite series 1 minus 1 plus 1 minus 1 and so forth. I want to know, does it converge or diverge? And if it converges, what is its sum? Alright. For this series, the partial sums are S sub 1 is equal to 1. S sub 2 is the sum of the first two terms, so that's 1 minus 1, that's 0. S sub 3 is the sum of the first three terms, which is 1. S sub 4 is the sum of the first four terms, and we can keep going on like this. If you look at the sequence of partial sums, you'll see that it's equal to 1, 0, 1, 0, 1, 0. And this is a divergent sequence. So that tells me that the series diverges and has no sum. So now let's look at the series. The sum is k goes from 1 to infinity of 1 over k times k plus 1, which looks like 1 over 1 times 2, plus 1 over 2 times 3, plus 1 over 3 times 4. And I want to know, does this series converge or diverge? And if it converges, what's its sum? So here we go. We look at our sequence of partial sums. And we see, oh, before we do that, let's do a little trick. Let's take this and using partial fractions, rewrite that as 1 over k minus 1 over k plus 1. Ooh, it's worth it to stop and look at stuff before you start charging ahead. Because once I do this, watch what happens. I sum up the end terms. Here they are written out. And when we do that, you can see that the last term here cancels out with the first term here. And that pattern continues. The last term here cancels out with the first term here. And so forth. And as we do that, all we'll be left with is this first term here and this last term here. So we get that our nth partial sum is equal to 1 minus 1 over n plus 1. So if we look at the limit as n goes to infinity of our partial sums, we'll see that that's equal to 1. So that tells us that our series converges and the sum of the series is equal to 1.